Yeah, I'm there. Whenever you're doing a Zoom recording, always have another device to Zoom open so you see what's actually happening. I learned that during the pandemic. Okay, so yes, I'm very glad to be here. Thanks very much to Timo for inviting me and convincing me. I didn't take much convincing. Davos was so close by. I'm still living here in Bern, so that's great. And we have an affinity with the community. We worked on a lot of things related to feature-oriented software development, though we didn't use that terminology that much in our work. As you may have understood, I'm being retired now for 2 years, but if you ask my wife, she won't agree. It's been great because I've been working for this little company called Think, and they've developed a platform for software and data analysis. It's a brief description, but I think I'll try and show you in the next 45 minutes or so what that really is. So there's a lot more to it than that. It's exciting for me for a number of reasons, because I'm working with a great team of really smart and highly motivated people, doing what I consider to be really exciting. But what's also exciting for me is that a lot of the stuff in this platform came out of the research group. I mean, not things that I personally invented, but people who were in the team invented. Just tons of stuff in there. And then I do things and I say, oh, wow, yes, I remember Lucas worked on that and Adrian worked on this. And it feels great to see that these research results aren't just prototypes that get thrown away in the end, but they actually come back and are making a real impact. And all these bits and pieces do fit together in interesting ways. So what I want to do today to you, I've got a couple of subtexts. As I said, I'm going to show you Glamorous Toolkit. It's a platform for software and data analysis. If you just want to use a half a dozen words to describe it, but there's a lot more to it than that. There are two kinds of subtext. So the main thing is I want to show it to you as an example of software variability. This is the real motor of the environment and the development approach, that we're modifying the environment all the time. And there are some affinities with the way you look at software variability in your environment, but I think it's a bit of a different take. So I want to show it to you and show you how software variability can play a role in the software development process itself. And the other subtext is, I think this is a super platform for doing research as well. So as Timo mentioned, I continue to have some contact with this group. I try and come in once a week, and I was co-supervising a student with him for the past couple of years as well, who's been using our platform to analyze GitHub actions. I'm not going to talk about that work today. I had a couple of papers on that already. I think it's super interesting work. But the message is you can use this platform for anything. So the ideas of moldable development really can apply to industrial problems or to research. And the key thing is what it allows you to do is whatever you're working on, you open it up to make the domain model underneath, to expose it, to make it visible to you so that you can talk to it. So it can answer questions for you. This is super interesting in research because you're analyzing data, you're analyzing a software system, you're analyzing whatever. You don't just want to have closed box tools that generate stuff for you. You want to make that data visible and interactive so that you can talk to it and have it answer questions to you. And this process of answering questions means that you are constantly adding new little tools to the environment. That's where the variability comes in. So you're adding new features to the environment during development. And this, of course, is also important in industry. I mean, we're a company, so everything that we do is done basically because we need it for our customers. Okay, enough talk on the first slide here. So to explain to you what an explainable system is, I think it's good to show you what is not an explainable system. So I think most of our software development is around non-explainable systems or cake systems. Any software system that you build nowadays, if you do normal development, and we've all been doing that for many years, essentially you have two views, now more recently 3 views of the software. The first is you have the running application. The second is you have the source code. And third, if you believe in tests, you also have the tests, okay? And it more or less stops there. The problem is that these three are more or less opaque. So here's a little example of an exercise that students in Timo's first year programming course developed using Java. And here I have an implementation in our environment in Glamorous Toolkit. And you can interact with it. I can click on the die, and that's about all I can do. And if I'm lucky, I happen to get a 6, probably no effect, I won't get one. It's completely random. That's pretty much all I can do here. Still didn't get a 6. Oh, come on. Everybody cheer the game on, huh? Maybe we can get it to give us a 6. Okay, and now I can make player D move. And then I can maybe play some more. You know, that's where it ends. And that's the end of it. This is typical with most of the software applications that you have. You can run the damn thing, but you can't ask questions of it. There are some exceptions to that, especially with development of web apps. But basically, the systems are opaque. So I can't ask any interesting questions. Okay, then we have software development environments. Yes. And we have our IDE, and we can look at the source code. Here I can see that there are all sorts of model entities. So I have a die, I have the game, I have all sorts of methods that I can look at. Let's see here. There's a player to move. That looks kind of interesting. Oh, it's not so much. It's just going to an accessor. I can muddle around here and stare at the source code for a while. So basically, staring at the source code is not much fun. And that's what you have in most development environments too. Sure, you can have some tools to query the software and so on, but staring at source code is really not a very effective way to understand the system. Then, of course, you can have tests. Tests are great, right? And you can run your tests, and your tests presumably run them all, and they're all green. The darn thing about a test is only interesting if it fails. So when it fails, I get a debugger, I can start inspecting, and I can start playing with it. Well, I can also look at the code of tests, because some interesting tests will be constructed in such a way that they tell you something about how to use the application. You know, frankly, how many times have you done that? I look a lot at tests, and very often I'm disappointed because the test is testing something not terribly interesting and it doesn't communicate too much to me. Occasionally I find a test and say, oh, wow, this test is really illustrating something. Somebody put some love and care into the design of this test so that we can learn something from it. But that's usually not the case. So what can you do about that? The history of GT goes back many years. As I said, the origins were in the research group, but we have something like 60 years of development of Glamorous Toolkit itself, and we've applied the principles of moldable development to the system itself. The idea is that you want to make a system explainable. So you want to take the domain concepts that are in there, queryable and explorable. The easiest way to show you that is to show you that. So here we have this source code view that we had before. It's not terribly interesting, but we go to the examples. What I showed you before were not actually tests. They're examples, which is almost the same thing. And if I take one of these guys, I can run it. So I can run this guy, and it's green. But the difference between a test, so a test has a setup like always, and I have some actions that I perform, and I have some assertions. But the key thing that's different is it returns an example. An example is an object that you can use in another example or another test. So every test becomes a setup potentially for another test. In fact, that's the way this guy's built up. So B enters and plays with A ahead of him was built up from a previous example in which B enters with token A ahead. And that in turn was built up from an earlier example in which player A enters and lands on token A, and so on. You say, oh, but tests aren't supposed to be dependent on each other. They're supposed to be independent. This violates one of the fundamental principles of the design of clean tests. Bollocks. It's nonsense. So we did some 15 years ago, we did analysis of Java tests, and we find that what that leads to is tons and tons of duplicated code in tests. And in fact, you have hidden dependencies. What happens then is if something fails, you get a whole bunch of tests failing. If, on the other hand, you make the dependencies explicit, if one test fails, it fails in one spot and one spot only, and you have a better idea where to go. So you can see the dependencies here in this examples map. And here we're looking at this test, and it's built up ultimately of this guy, which is an empty game. So I have several steps of building these tests here. Okay, so I said we can actually do something with these examples now. You can compose them, but what's much more interesting is that you can actually evaluate them and inspect them. Now, this looks pretty much like we saw before, but it's different. This is not the GUI. This is actually the GUI view here. This is, well, you might recognize it if I show you this instead. What's that? That's an object inspector. The object inspector is what you see usually if a test fails. And you get a generic object inspector, and they're all the same in all development environments, and they look like this. Well, what we do to make a system explainable is we add different views to these objects. So we can have the board view, which is the GUI view. That's kind of a very rich, complex view. But we have a whole bunch of much simpler views. So here we have the list of all the players, list of all the squares, the list of all the moves. And the cool thing about this is now we can explore this model. So we can have a look. We can see that player A is in the state that it started. Player B has to play. So we can dive in and we can see what the state is. So now from exploring the game, I can go to explore the actual player and have a look at this guy and at its views. These views don't come from nowhere. Somebody has to program them. So you think, oh my God, that's going to be horrible. Well, as we'll see, and what I'll try and convince you is most of these views are super simple to implement. They're just a few lines of code. Some of them are more complicated, like this GUI guy. But once I had this GUI built up, I could reuse it to do all sorts of other things. This is the same view we had before, but now we're using it to highlight where player B is in the board. And we have moves here. Here we can see what player B did just by reusing this graphical user element. So we can move around this guy. Let me see. So now we've got this view here. We can see what player A did initially. Player A rolled the 6, and we can walk through this. Now we've got kind of a, we call it a debugger, but we can explore the history of the game. So, then player A got another piece in and rolled and got its token in, and it landed here, but it already had a token in place. So what happened in the logic of the game, this guy had to bounce forward to another position. And then what happened? Well, then player A rolled another 6 and he moved his big token and moved again, and he got in this funny position. And then player B came in, and then it rolled a 1 and landed on A and was back. It says, okay, fine. Well, what if that hadn't happened? What if at this stage, instead of player B, when it rolled a 1, instead of moving B, what if it had rolled a 6 and moved its token B in? Well, let's go back here. What we can do is we can talk to this object. And here is a little playground, a contextual playground. So this is kind of like a REPL, not quite. But basically, you can write code here, and the code is bound to the context of the object. This is super important, as we'll see later. So self is bound to this guy, so it's this. And we also have access to the to all of the instance variables and so on of that object, which is also going to be super useful, as we'll see later. So now I can run this and inspect the result. And the result is an instance of the Ludo recording game, which only played the moves up until this state. Let's see all the moves. So now what we could do is we can roll a 6, and now player B has to move. You can see the views are updated there. And we want, so I can do things programmatically, or I can also interact with this guy. It's a fully fledged GUI, so I can actually use it. So let's just click on B here. And something happened, and it went really fast. Let's go to, wait a moment, let's make sure this is updated. So what happened? Player B rolled a 6, big B got in, and now player little b got a 6. It came in, hit its own token, which forced it to go to the next square, which it landed on another guy's token and forced him to go back. So we can, once we have this moldable object, we can start adding views and making it richer. And as we ask questions, we can start adding new views and elaborating the environment so it becomes explorable. So this is something that you couldn't do with the closed game, because you can't really explore the state and see where it is. And you couldn't really do it with the tests, because the tests only give you a static snapshot, and they're either green or they're red, and there was nothing red here. And staring at the source code would be really, really hard to figure this out. So once you have a system and make it explainable like this, then you can start asking interesting questions. Let's see, where did I want to go now? Yes. Yes. Now, the examples are also live objects. The Glamorous Toolkit, one of the key tools inside it is a knowledge base called Lepeter. And it's supposed to make you think a little bit of Jupyter, but it's different as well because it's really a full-fledged CMS. So it's a wiki. And it's not only text, but it also contains live examples. So this is an example which has been embedded here into the live documentation. And of course, it's completely live. You can interact with it. And the interesting cases, for example, a move to the very end or an impossible move. This one's kind of cool. We can zoom in on it if we like. We can see that here we had some problems that player B rolled a 6 and it just couldn't do anything. So it's forced not to do anything. So it rolled a 6, but it's stuck. So it just stays where it is. So we can have all of these different scenarios. They're examples, they're tests, they have assertions, but they also end up being reusable in documentation. So by simply doing one small tiny thing to test, returning an object, you can actually do so much. You can compose the test, you can eliminate duplication in code, and finally you have examples that you can explore, and you can also embed them into documentation. I'm going to show you a bunch of little examples. I'm not going to show you any industrial examples. So one of our big customers is a company in Ticino, Lifeware. They provide services for life insurance companies, basically being able to take all of their contracts and put them into a proper object-oriented database. And one of the big things where they need help is in migrating their existing contracts to the new platform. That's a lot of work because every life insurance company does it differently. So where we're trying to help them is using our platform to help in the migration projects by making that not only the domain model explainable, but also the underlying technology that you use to do the migration explainable and explorable. Here's something that I was doing just for myself because I have a website, and when I left the university, I wanted to keep the old website there, but I also wanted a new personal website. So I migrated all of my personal stuff to GitHub Pages. And I said, you know, the more and more you use this stuff, you say, I have a great tool to help me manage this. I should apply GT here. I have also a great movie fan and was using it to help adjust subtitles of movies. Once you build a little tool, it just says, oh, that's so much nicer than doing it with scripts. So here I have a view of my website. And I have an overview of some of the statistics, the number of pages and so on. I get the list of the pages and I can go to a particular page. It's telling me interesting information about some things, missing a title. Oh, I also like this page, Dugstools I've attended. Links inside the whole website. And here's something, missing status. So I just loaded this. And there's a whole bunch of pages that have missing status. This is the HTTP status. So instead of having just views, there are other tools in the environment that you can mold or can be molded in different ways. In particular, you can add actions. So here I have check status, and what it's going to do is it's actually doing HTTP pings to all of these links to see what's going on here. And I can also stop this, so it's not running here in the background. So we've stopped that, and we see a bunch of pages with broken links. So here was Sainer in Austrian AC conferences 2013. So we can go there and see which pages that was in. Oh yeah, that's one of my pages, which is the past. That's the log of the places I can see this view, which is the content. It's all marked down. But I also have an action here, which allows me to go to the actual website. Right, so I see that this is a page of the history of places where I talked or participated as this or that. And it's clear there are going to be lots of broken links there. So those are things I'm not too worried about. But I can also see, for example, here's a bit richer view. And this is a map of the website. It's not a very big website, but you can also apply it to bigger ones. And I can see the route which I started from. That's the About page. And the blue ones are navigation, the pages that are in the navigation bar. The green ones are the ones that I can reach by following links from the pages here. This is all live, by the way. You know, so these are objects. It's not a picture. And that's the key thing. Everything you see, it's live. It's not just a picture. So you can click on these guys and really explore them. You can also say, well, what the heck are these unreachable things, the red guys? What are they? There are some strange things here. And oh yeah, well, this is kind of a GitHub pages, source repo, and so on. I can go back to the overview and say, okay, what are all these unreachable pages? And say, oh yeah, some of these are really, I don't really care about them. Some pages are hidden. I only want to have an explicit link myself to share. But there's some log things here that don't seem to be linked in. Is that possible? So either there's something wrong with the website, or maybe there's something wrong in which I'm calculating the links, but this is information that's interesting to me. So I have to explore that and see, is there something that I have to fix? I want to give you a feeling how the process works. So up until now, I'm just showing you existing views that were in the system, ones that we'd already created. So here's an example, which is not too far from what we were doing with Pablo, with Timo's student. We have some information that's somewhere. We either have existing software, existing code, or we have data. In this particular case, we have on GitHub, we use GitHub for all of our projects, and there's a Fink organization. And there's, of course, GitHub has a REST API and also has a GraphQL API, which we also have an interface to. There's a page in the book about that as well. You can access this API from GT interactively or programmatically, I should say. So here's the URL that we would use from the GitHub API. And we can ping that and download the data, and we see that it's JSON data. And once we see that it's JSON data, we say, okay, well, we have a JSON parser, so let's parse that and get a dictionary out of it. So here's the dictionary. So, okay, but the dictionary is not a domain concept for GitHub organizations. So what we really want to do, and this is an important step, the first thing we actually want to do is we want to wrap this up. So we say, my organization, new and raw data is this dictionary. Now, this is a fundamental change. Usually when you program, where do you start programming? Text editor, right? So, or you might write a test first. You either start and say, oh, I create a class and I start creating methods and maybe some tests so that here we turn that around. We start from the objects. Then when we find something interesting, we extract methods. When we find interesting objects, we extract examples, turn them into tests. Of course, this class doesn't exist yet, so we'll just create it. It's a fix-it. So I'll create the class. And I get a template here. I have to define a package, so I'll call it, give it the Vamos package. And bang, now this class exists. Okay. Of course, this method raw data doesn't exist, so let's create that. And we're just going to save that data in an instance variable. So this is going to be a setter. And of course, this instance variable doesn't exist, so we're going to create it. Please do it. And there. We just programmed a new class and a new method, and this guy exists and we can explore it. We can inspect it. Bang. Okay, now we have an object. Not in the text editor, I'm not in a coder, I'm in the inspector. And here's the raw data. So the raw data, I've got a bunch of items here, and I look through it and say, what is all this stuff? Okay, there's not too much stuff here, but hey, wow, this is interesting. There's a repos URL here. That looks like the same API we had before. So that's a cool thing that we'd like to get access to. So let's open up our contextual playground, and raw data. It's part of our context, so we can access this instance variable directly. We don't need a getter. And we want to get this repos URL. And bang, there it is. We have it. What can we do with this? Well, this is a URL, so let's just assign it to a URL variable here. And wait a moment, we did something like this earlier, didn't we? So if we want to access it, we just want to get the JSON from this guy. And then we want to get a dictionary from that guy. Right? Now we can evaluate that. And now we've got a bunch of dictionaries from GitHub, which is all of the repositories from our organization. And now we say, okay, well, this is a cool thing. So let's extract that as a method. So this is self-repos. That's much more interesting. But we'll do it anyway. It complains a bit. And here's the code it generated, okay? So it's slightly rewritten, but we're grabbing the URL from this location, we get the data, and then we parse it, and we get the dictionary. Okay, so that's pretty cool. Here's the dictionary. And this list of dictionaries, that's actually pretty useful. This view, we'd actually like that view over there. And we can do that in a variety of ways, but I'll just switch here to the meta view and say, let's create myself a new method. So DT repos for view. The name of the method is completely irrelevant. What's important is it has to take an argument, which is a view, and it's kind of a factory. And it has an annotation. So small talk, that's a pragma in the angle brackets, but this is just like annotations in Java. It's how the test runner knows which methods are tests, right? It just goes through them, so it's meta information. It's exactly the same thing here. And we'll ask this guy, to create a list view, and give the view a title. Yeah. Repos. And we'll give it a priority because the views are in some order. So I'll give it a low priority of 10. So it should appear before some of the other views. And the items. What are the items? Well, they're the self repos. And we commit that. There it is. So it's updated immediately. You notice, you see how things are happening here. So instead of having to go to the text editor, maybe write some, and then going somewhere else, and then running some code that will actually create the application and saying, oh no, that's not what I want. Going back to the text editor, you're always in the environment, you're always in the context of a live object, which you can talk to, you can access its code, and you can update it. And there's nothing special about Smalltalk as a dynamic language. You can do this stuff with other languages too. It just requires a little bit more will on the part of the people who build the environment. So there's nothing magical about Smalltalk. This is one of the messages. It's easier here, but there's also a lot of investment in this. Okay, so we have this dictionary guy, and we go into one of them, and we look, oh God, look at all of this. These are dictionaries as well. This is not so cool. We don't want dictionaries, we want objects, right? Watching the time. I have a few more steps, but there are lots of things that I want to show you. So let me just tell you quickly what I was going to do. I was going to wrap these dictionaries up as well as repository objects. We'll give them a name, we'll update the views, and then we can start to navigate from the organization to the individual repositories. It's a demo that takes a few minutes, but I want to save time for other things and also for questions and answers. After a few steps of this, you get something that looks like this. So this is the full demo. We have repositories. We also have events. We can also see the raw data as before. We can go into a particular repository, for example, the G-Toolkit repository. We can see who are the contributors to this. So we have, these are also going to be objects, and we can dive into a particular person and see what they did in this particular project here. So basically what you end up doing is in a few steps, iteratively, as you ask questions and as they occur to you, you start adding new kinds of views. And most of the views are pretty simple. Let me plow ahead. So what I showed you in the second step was a couple of examples of different kinds of moldable applications, explainable systems. And then the last thing, I gave you a little bit of a hint of the process. You explore, you interact with the objects. When you find something interesting, you create a new domain object, or you create a view, or you create an action. And slowly your application grows as you ask questions and you answer them with the help of these custom tools. Each of these custom tools is a feature. Now, how does this work? So let's have a quick look at the technology. So this works because the tools are moldable. We have an object inspector, which is moldable, and there's several other tools that are moldable. These tools are open. So the inspector is open. When it sees an object, it asks that object, what are your views? This is exactly the same as the test runner in Java. It sees a class and it sees, oh, you've got methods that are annotated with tests. I guess I should be able to run these things. But the technology is the same. It's well known. But there are many different tools, and the moldable tools, they adapt themselves to the things that they interact with. So here's an example again of the Ludo game. And if we look at some of these views, this is the code that we have here behind it. It's pretty similar to what we were writing before. We have a method with a boilerplate name. We have the pragma, and we have a view, which we ask it to create the view for us. There are a bunch of prepackaged kinds of views you can have, or you can have a more complex and richer kind of a view, like the map that we saw of the website or the Ludo game itself. Those have to be handcrafted. But many of the views are pretty simple. So here we have just a list of squares, and we say which are the columns. We want to have an index with the token and the state, and we have the code to extract that information and display it. So most of the methods are tiny. We also have views in the coder. So it's not just the object inspector. Here, for example, if I browse, this is in the class browser here. The class browser shows us not only the methods, but also the icons that are generated. Each of these is a method, and I want to see these icons, so I can browse them. Oh yeah, this is the one that I want. I want the down icon. It's just a method, but here it is. So that's much richer than the methods view. Here's the class color. It has a whole bunch of methods too, but it has a view which is the list of all the colors and the method names. So I said, oh yeah, I want to use this guy. They're defined, these views are defined pretty much in the same way. It's also, except instead of a GT view, for the object inspector, it's a GT class view, which tells the coder that it's adding a new view. So it's pretty much the same. And this one is kind of cool. This is the class that defines the slideshow, the live slideshow. And it has a view which is called slideshow. And it also has some buttons here, so I can actually inspect the slideshow and see the individual slides. And I can go to, which slide is this one? This is the slide about the coder views. So this is the slide that we're looking at here. We also, this is something new that we've been working with a little bit more recently, which is moldable exceptions. So what we want to do is take the debugger itself and make it moldable. So here's a case where we have a Ludo game, and player C is supposed to roll the die and play. So we roll the die, but instead of moving player C, we move player B. What's going to happen? So this, if I run that, I get bang into the debugger. The view that you would normally see in the debugger is this, the stack view. You get some experience with debuggers, but most often when people see a debugger view, they immediately close it and go back and stare at the source code. But what if instead of having just the stack view, you could have a dedicated debugger view? So here I see the state of the game. We can see what moves there are, and it has a useful message saying token B does not belong to current player. We can actually get reuse some of these views and have something more useful inside the debugger. So this is also something that we've been using increasingly for some of our applications. Let me move ahead a little bit more quickly. Just want to show you a few more examples. Yes, we have custom actions. Before we saw we could say in the playground, we play the game to here, but we can also make this an action. So put that in a button. So if you see something you want to do over and over again, you want to find it quickly, you make it into a button. It's not complex. Instead of a GT view, it's a GT action. Nothing surprising there, but terribly useful. And what I haven't showed you so far is custom searches. So very often in your domain, you may have lots of objects of similar types. And we have a search facility for GT itself. You can search through the entire system for methods and classes and packages using various criteria. But here, for example, I can search my website. I can search, for example, for Vamos. And I'm searching not only for page content, but also for names and links. These are two different searches. And I would find this guy, and okay, here's a particular page, and it mentions, yeah, it's the home page, which is mentioning that I'm giving this talk. And the way this is done is using annotations. So this is a GT search, and I just define a whole bunch of those. Let's close that up. By the way, I was always doing this with a keyboard shortcut. So if I click on something, it happens. If I alt-click, it's going to show me the code behind it, which is super useful for understanding the system itself. Okay, so let's step back a bit. One way Tudor likes to describe what moldable development is about. All of these custom tools, you can think of them as features, but you can also think of them as defining a language of composable operators to support decision-making. It's all about answering questions to support the process of decision-making. The custom tools, the moldable tools on the one hand, they bring in custom tools. So here is the object inspector. Again, this is not a picture. Here we have an object. This is a Ludo game here, with its plain old raw view, and we've augmented it with a board view, a moves view, and this replay action. And when it gets into the object inspector here, The object inspector adapts itself dynamically, and then what we get is this richer view in the inspector. It's completely happens dynamically. So we've got features, but the features are brought in dynamically. There's not much composition. There are not too many constraints. A view can be enabled or disabled. So one common view is an empty view. So if I decide I don't need a view, well, there are no list of players or something, then I don't show it. Or if I have a file reference and I'm not a directory, but a file, I'm not going to show the directory view. The custom views are very fine-grained. Here's a query. So I'm asking the system, give me all of the methods with the GTView pragma. Here's a long list of them, which is being computed dynamically. And here again, this result also has has several custom views. So here we're looking at all of the list of methods that's being dynamically computed. In the system, there are several thousand of them. So the system has a lot of views that are built in. And here, on average, there are less than a dozen lines of code. There are some long views, but most of them are quite short. And the total will be there in a moment. This is so slow, it should be faster. Most queries over the system are quite fast, yeah. So just over 3,000 views in the system. There are fewer custom actions and fewer spotter searches, but views, there are many of them. Here's an example of the tools being composable. So this is a page in the book which is explaining Smalltalk method syntax. And it's a custom-made tool that highlights us in a method what are the different kinds of syntactic elements in a Smalltalk method, which is nice. But this is a custom tool that's being defined. The tool is just a class, so we can actually go in here. Ooh. And if I inspect this particular method here, I get a view of the compiled method. The compiled method is one of the entities in the system which has lots and lots of views. So this happens to be a slide method, so it's showing me the slide. I can see the source code, I can see the versions, the Git history, I can see the bytecode, I can see the abstract syntax tree, but I can also see the syntax explanation. So I could just reuse that inside of a view. Well, everything that you invest some effort into very often can be reused to enrich your environment. And it's not just Smalltalk. So we're using this, of course, to analyze lots of different systems. Here we've got some Ruby code. And in this Ruby code, I also have a syntax explanation. So here I have a syntax explanation, which is being applied to Ruby code. We're also working a lot with Python. So we actually have a bridge to a Python execution environment. So you can actually have they're not digital, it's kind of a digital twin. So we have the objects in the Python environment, but also reflected in our environment so that we can see what's going on. So that's quite common. Also similar to what we're doing with AWS, so that we have a view from our environment monitor showing us what's happening in the lots and lots of different clusters. This is the almost final slide. This is showing all of the classes in the system, and in blue are the ones that have custom views. We're getting about actions and searches, all sorts of other tools. I didn't talk to you about a number of other ways in which the system can be. So this is BL element. This is the root of the graphical hierarchy. Of course, this is live. It's not just a picture. And the things in green are where we have examples. So the system itself is covered quite heavily by a lot of the tools that we apply to other systems, we apply to the system itself. Let me wrap up. Finally, some bullet points. So takeaway messages, the software systems, they become explainable by embracing variability in the tools themselves. Like this works because the IDE, the inspector, the debugger, the class browser, they're moldable and they can be extended dynamically with features. The dimensions of the variability, they're driven by stakeholder needs. Nobody does a big bang design. When you're actually interacting and developing the system, you come up with questions, say, I wish I had a view for that. Well, you just go and do it. You just add the custom features because it's super cheap to do. You get away with it because the actual investment in building a custom tool is paid back immediately. If this were hard to do, nobody would do it. But because it's easy to do, of course, there's a learning curve. Once you learn how to do it, it becomes natural. You're developing and you just add these custom tools as you need them. And that means that the customization is part of the moldable development process. So that's why that works. The whole system is open source. If you go to gtoolkit.com, you can download it for free. We have a Discord for the community, people to ask questions, and there are lots of people doing amazing things with it. This should be the end of my talk, but just this morning, I saw something which was so cool, and it fits with the theme of this morning. So maybe I should just show it without any comment. And there's a tutor, we're talking to it. We create an assistant, and we're asking the assistant, can you write me a script that lists all the classes currently defined? You can see where this is going. So we're playing with this technology right now. And we get a view on this, right? Like we're applying multiple development to the process of talking to ChatGPT. Let me see. And let's dive in. Let's see what happens. Certainly, says the assistant, here's some code. It looks pretty good. What do I know about Smalltalk? Huh? Well, wait a moment. There's something wrong there. We run it and we get some errors. ChatGPT hallucinating a bit. Back and we want to talk to the assistant again, I think. It's a very short video, so it's much longer. My apologies. Let's correct that. Still doesn't look quite right. And that goes on from anyway, I'll let that continue to play. For me, the lesson is the following from my own little experience playing with ChatGPT. It's good for things when you can check the results. So if I want to write a letter in a language I don't know so well, I can write a draft and I can say, hey, can you please translate this? Or if I have an outline of the letter or some draft of something, you can expand it. It expands it. I can check it and correct it and continue. But if I ask it a technical question, very often the answer is, wow, that's great, fantastic, it solved my problem. I try and apply it, and I realize it's complete nonsense. It's garbage. So if you can check the results, they might be useful. But ultimately, what do I want to use it for? My big problem in software development is not writing the code. The amount of time I spend writing code is minimal. The problem I have is understanding the system. So if I could use ChatGPT, not to write code for me, I can do that myself, but to actually answer questions that I can't answer otherwise and help me in the process of making systems explainable, then I see for me there would be a lot more added value. We're starting to experiment with this. I don't know where it's going. That's another colleague of mine, Fight, who was working on the prototype. Okay, that's it. So that took a lot longer than expected.
I think the technology slowed down the speed of the presentation. I'm terribly sorry for this.
It's this adapter.
We could follow anyway, although it was probably for you a bit stressful. Anyway, we have time for 3 questions. Yes, Wesley?
First of all, thank you very much for the presentation, Oscar. It's quite motivating, your enthusiasm present about your work, that you enjoy what you're doing, so this is motivating. About my question, when you start presenting the tool would be, this is a tool about testing, then you start showing how the different tests is connected to each other, so there is traceability, and then you start showing about monitoring. And then there is this concept, so domain analysis, and it goes on the list, right? You started talking about refactoring. So it seems that you have a tool that's a software engineering solution that crosses many different fields, and you somehow brings customization and variability to glue all them together. So my question is, what are your reflections about the need of having these multi-field kind of tools and your vision on the use of variability to glue them together?
On the use of
variability and customization to put them together.
Well, for us, it's extremely important that the tool be customizable. And as we detect needs, we take new tools and say, okay, well, how can we make this moldable? So the debugger was one of the last things that we started to work with. It was one of the first things in Andre Kish's PhD thesis. He's one of the employees of Think. He did an amazing thesis some 7 or 8 years ago on moldable tools. And one of his examples was making debuggers moldable. But in his approach, the cost of molding these tools was still rather high. So we were looking for ways of making it cheaper and cheaper to do. And we still didn't have the solution until he came up with moldable exceptions. This is relatively recent, only in the past year or so. And we've started to add some moldable exceptions to different kinds of applications. So the message is, look for opportunities where a tool does a fixed job when you'd like it to do different things. So the thing is, closed tools have very limited applicability. Every problem is different. So our idea is, instead of using fixed closed tools, you want to create new tools dynamically and have it so cheap that you say, you don't even think about it. You just write the tool because the tool is so tiny and you plug it in and then it's always there. But the only way that can work is if the environment has tools that are moldable. So we can add these views because the coder and the debugger and the inspector allow you to add the views. So you have to open these tools up. So you have to ask that for your own environment. How would I open these tools to make them tell me more questions? So we're not saying you have to use this environment. We want to see other people applying it to their programming environments to make them moldable, extensible, and customizable.
Very, very nice and convincing demonstrations, and I'm really looking forward to trying it out myself later on. So I'm wondering, so if you're programming nowadays, most IDEs or development tools look quite different, as you already mentioned, Eclipse or IntelliJ or whatever you use. Would you say that, or is there any advantage of these other traditional tools over that one? I think that's of course much more interactive, but for example, to get an overview of a new project, is it what I typically do is look at the files and perhaps look at the classes or so, and then look at some places in more detail. So is that something which changes with such a system? Or
yeah, so the two things which really bug me about the traditional development environments, and from that experience as IntelliJ or Eclipse or NetBeans, I don't see any difference with them. One is you're always starting from the text edit. It's fundamentally broken, and I noticed it myself. It took me a year of working with GT before I realized every time I wanted to start coding and I opened the text editor, I slap myself, say, no, I'm doing this wrong. Where should I be starting from? And I go to a notebook page and I write some code and get an object. And then I start working with that. We call it object-oriented programming, but it ain't. It's class-oriented programming. This is object-oriented programming. Here you're programming with the objects. That's different. So that's one thing. The second thing that I think is fundamentally, well, not fundamentally wrong, but it's really limiting, is if you extend these environments, you write a plugin. It's written an Eclipse plugin. Is it fun? Is it something you say, oh, I need this, I'm going to write a plugin? You do that every day? I writing views all the time. I just, oh, that'll take me 30 seconds. That'll take me a minute. Oh, that'll take me a bit more time. I have to create something custom, really a bit more complex. But yeah, it's going to pay off in the long run. But writing a plugin for an IDE, and then once you got that plugin, it's a standalone tool. It doesn't talk to other tools. They don't connect to each other. Here, when tools, part of the whole flow, you just bing, 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 you flow from one object to another, because then you can, I didn't use the word narrative, but one of our favorite words is narratives. You want to tell stories with this. You want to answer questions, create a narrative that may be something in a discussion on Slack, or it might end up being a notebook page, which connects all of these bits and pieces. So those are the two things that I see that are limiting in existing IDEs.
There was another question. It's really cool. It reminds you of like Emacs and all of these GNOME, Vala things, and how they call it, the GUI system. But like I think the biggest issue with these moldable systems is getting back to some safe state. So like if you messed up, if you made a mistake, if the environment for some reason fails, you would have to get back to some safe state. But I think that this moldable, this Explainable toolkit stuff with Smalltalk could provide some kind of snapshotting tool, right? So
well, that's built into the underlying Smalltalk environment. So if the system does crash, you can replay things and get back more or less to where you were. But it is clunky. That's something that should really be improved.
Could you?
Yeah, that's a really interesting idea. We haven't done that, but that could be super cool. We do have GT tools dedicated to replaying snapshots and getting back, but that could definitely be better.
Like playing multidimensional chess, but with GT and jumping back in time to different.
It's a cool idea.
There was another question.
Yeah. Thanks for the presentation. It's a very interesting tool. I mean, they mentioned about Emacs. It feels a lot with like Emacs, but written in Smalltalk. And additionally, I think this entire thing with views that provides like much better indexability of the objects that you have in the environment.
Yeah, absolutely. Emacs is a important precursor.
I was wondering, there was a slide about interoperability with other languages, and I think that the environment itself is written in Smalltalk, very likely Squeak, because you also have a lot of work on Squeak. But I was wondering how does it exactly work with the different languages? Does that mean that the environment is capable of reflecting on code written in other languages? But does that mean the extensibility is exclusively over Smalltalk?
So basically, you have a bridge to other languages. I don't know which of these things I have to run. I think this I need. So basically, we have to set up the bridge to the other execution environment, and it takes a few moments to set up. And then once we demo effect, I did this yesterday, and I made sure that the Python stuff was loaded in here and working. Should have been okay. No. Oh, there's something wrong here. I did get it to work momentarily. There's something wrong here. But basically, you're going to be talking to the other execution environment. Yeah, that's expected. Good. And here I have a movies database. And if everything works, then I can get a view of this collection of movies, which is actually in Python, and the views are actually written in Python. And I have the bridge going back here. But it's a bit finicky when you set up these language bridges. I checked to make sure it was working yesterday, but I don't know. Yesterday it worked, today it doesn't. Why?
There was another question by before we maybe.
Yeah, thank you very much. Very inspiring presentation. I'm curious if you work with companies, what they want from you. They want to represent their existing code bases or environments in your environment, so that you have a multi-language representation where you can do more things than they can do now. So,
it's the way Tudor explains it. We try and do a lot of evangelizing, but we don't have very many customers. And that's not a problem. We just want to have some customers who are really committed. So the way Tudor likes to describe it, we have two kinds of customers. One is a little bit less interesting, but still fun, and the other is more interesting for us. The first kind of customer is, they have a serious problem. They've messed up. They've tried a few things. They know they don't work. They're desperate for a solution. They don't care what our technology is. They want us to solve their problem. So we had a few customers like that in the past. We solved their problem. They said, great. You guys are doing cool stuff, but we don't think it's good for our day-to-day work. Goodbye. We'll see you later. So that's one kind of customer. And the other customer is, there's somebody there who gets it. That person inside the company realized that there's a competitive advantage in LifeWare. They realize that if this really works, the biggest cost, the biggest risk in getting new customers, life insurance companies, is this migration process. If that messes up, if they're late, it costs them a lot of money. If we can help them get that done fast, then they have a competitive advantage. So there has to be somebody there in the company who realizes that making systems explainable gives them an edge over the competitors. So we don't have too many people. So you need the angels inside the company who recognize it, and they do the selling to other people. And then you have to have some projects that get successful. So we're in that situation now with another company, looking at some pilot projects and showing them some really interesting things. It's hard to convince them to do things differently because there is a paradigm shift here. Developing in a different way, and people don't like change. So.
One more, yes.
Yeah. Okay. So thank you. Just a quick question. So you have basically an environment, development environment that is highly customizable, which means that potentially all your developers could have their own development environment. I'm curious to know if they do they share what they develop for them between them, or is everyone just making their own views and their own tools?
This is all shared. So everything is, all of the development, most of the development is done using Git projects. So when we extend the system, all of our extensions become available for other people. So the extensions that I've defined to GT are available to my colleagues as well. We have a continuous integration process, so everything is continuously being updated and extended. And we're doing no branching. So we find bugs very fast and fix them. So when the build breaks, it gets fixed quickly. On the other hand, refer again to Tudor, the CEO, with his vision. He considers this a prototype. But his vision is he wants to see something like GT, but really running on the internet. Because right now, collaboration is pretty clunky. When we have to collaborate something, we start a Slack huddle, and then that doesn't work. So we switch to Zoom so that the other person can control the keyboard, and we go back and forth remotely working on one image. So you don't have the images connected to each other. This is legacy from the original Smalltalk design. And it works, but it's really clunky. So you can imagine something much, much more interactive and distributed and collaborative. So that's where we'd like to be some years, but this is a long game. So for now, this is what we have, and it's pretty good, but we see how life could be much better.